Okay, let us consider this question. Albert takes 12 days to do a job working alone. Bob takes 15 days to do the same job working alone. Albert, Bob, along with Christopher, they finish job in 3 days. So Albert, Bob, Christopher, 12 days, 15 days, 3 days. Let us consider an LCM. Why LCM? Because it is easy to calculate, right? If you take it as a multiple. So total work, or you can say total effort, it's up to you. If you take it as LCM of these 60, so what I am trying to do is to understand that A takes 12 days to finish 60 units. That means each day how many units he is doing. Work per day. What is work per day? It is capability of a person, right? Effort. So A can do 5 units per day, B can do 4 units per day. All three put together can do 20 units per day. Right? 12 into 5, 60, 15 into 4, 60, 3 into 20, 60. Now out of 20, contribution of A is 5, contribution of B is just 4. So the remaining 11 is contributed by whom? C. Remaining 11 is contributed by C. So 11 out of 60. So 11 out of 20 is C's contribution, right? 11 out of 20. So if you consider share of Christopher's share is doing 11 out of 20 every day, right? He is doing 11 out of 20 every day. Now they are working for 3 days, right? In 3 days, C is contributing 11 into 3, A is contributing 5 into 3, B is contributing 4 into 3. Put together is 60, right? 33 plus 15, 48 plus 12, 60. Right? This is how it is happening. So every day, Christopher is contributing 11 out of 20 units. Then what is the total share? The total amount 3,600. So Christopher should be paid 1980, a major chunk. 1980 out of 3,600. Major share has to go to Christopher. So that is about the share. Next, let us consider in terms of if Christopher alone does the job. It is very simple. 3 into 20, 60, 15 into 4, 60, 12 into 5, 60. Now, 11 into how much is 60? That is very simple, 60 by 11. So, how much that comes to? Let's see first answer. He can finish job in close to 5.5 days. Please take down fast. Similar problem can be taken with respect to pipes and cisterns. Tap A takes 20 minutes to fill a tank. Operating alone. Tap B takes 30 minutes to fill the tank operating alone. If taps A, B and C are opened simultaneously, it takes 4 more minutes to fill the tank than when only A and B are opened simultaneously. In how much time tap C can empty the full tank? If you wish to, you can take this figure. Try this problem. Okay. Tap A, tap B, tap A plus B, tap A plus B plus C. Tap A takes 20 minutes, tap B takes 30 minutes, no other information is given. So if it LCM, I would consider it as capacity of the tank. Okay, 20 and 30 multiple. So capacity of the tank, let us say it is in liters, 60 liters. So tank's capacity is 60 liters. Then per minute, how many liters is being full? Right? Liters per minute. How many liters per minute is being filled by tap A? 3 liters per minute. With respect to tap B, 2 liters per minute. So if taps A and B are operating together, then they can fill 5 liters. Right? So they can fill 5 liters. To fill 60 liters, they take how much time? 12 minutes. It says if A, B and C are opened, they take 4 more minutes. That is, they take 16 minutes. 16 minutes. So to fill 60 liters, if they take 16 minutes, so per minute how many liters are being full? 4.75. So 4.75 liters are being filled by tap A, B and C together. Now you know A and B alone can fill 5 liters, but because of tap C, 4.75 liters are only being full, which means what is happening? Remaining 0.25. It is being emptied by tap C. Now if we have to consider tap C is operating alone, then it has to empty full tank. So it can empty 0.25 liters in 0.25 liters in 1 minute. So to empty 60, it will take how much time? So it will take 240 minutes. Let us recap. Tap A takes 20 minutes, tap B takes 30 minutes. So LCM 60, 23 is 60, 32 is 60. So tap A can fill 3 liters, tap B can fill 2 liters, 3 plus 2, 5. Right? So to fill 60 liters they take 12 minutes. So it takes 4 more minutes to fill the tank. Right? So in this case it takes 4 minutes, that is 16 minutes. So 16 minutes per minute, how many liters are being full? Just 4.75. Just 4.75, which means 0.25 liters is being emptied by tap C alone. So that means for 1 liter it takes 4 minutes. For 6 liters it takes 240 minutes. 240 minutes or 4 hours. So in 4 hours the tank will be emptied by tap C. Please take down fast. Okay. Let us take one more problem. Albert and Bob working together can finish a job in 24 days. They start the job and after 15 days Albert leaves. It takes Bob 15 more days to finish the task. It takes Bob 15 more days to finish the task. If the total compensation is 36,000 rupees, then find Albert's share. Also find how many days Bob would take Bob would have taken to finish the complete task if he had to work alone. Try this problem. Okay. Albert, Bob, Albert plus Bob, days 24, work. Here we're talking about 15 days. What happened in the real situation? If they work together, they can finish the job in just 24 days. What happened here is they worked together for 15 days. Then in 15 more days, Albert left. So only Bob was there. This is what happened. Okay? The two ways of doing it. One, if you in a conventional method, I would like to consider 15 as well as 24, LCM of 15 and 24. Okay? So here, if you consider 120 as a total work, Albert and Bob put together, they worked for 5 days. Now what happened if they work for 5 days, just 15 days? They work together for 15 days, right? If they work for 24 days, 120 units will be done. If they work for 15 days, how many units of work will be done? 15 into 5, 75, right? So what is the work left out? Left out work is 45. Who did the remaining work? B did the remaining work. So B did the remaining work of 45 days in how 45 units in how many days? 15 days. So in 15 days he finished 45 units. So per day what is his contribution? 3. So work will be done 15 into 5, 75, right? So what is the work left out? Left out work is 45. Who did the remaining work? B did the remaining work. So B did the remaining work of 45 days in how 45 units in how many days? 15 days. So in 15 days he finished 45 units. So per day what is his contribution? 3, right? So how many days Bob would have taken to finish the complete task, right? So here days work. In 15 days he'll finish 45 units. So to finish 120 units he'll take how many days? More work, more days, right? So 1/3 of the time. So that is 40 days. This is about Bob. So Bob will take 40 days to finish the complete task. That is one aspect. The second aspect is find Albert's share. Find Albert's share. Now if you observe, every day's contribution of B is 3 out of 5. This is work per day, right? That means remaining work is done by Albert. So every day's contribution of Albert is 2. But it is not given in terms of 2 out of 5. Why? Because Albert and Bob did not work together always. Only for some part of the time they worked together. So Albert worked only for 15 days, right? In this case. So in 15 days, how much work he has done? 30 units he has done. Right? 30 out of how much? 120. So Albert's contribution is 30 out of 120 units. Therefore, he should get share in a similar way. Therefore, Albert's share is 30 out of 120 upon 36,000. So he should get 1/4 of the share, that is 9,000 rupees he should get. Please take down fast. Okay. Let us take one more question. Albert takes 10 days to do a job working alone, which takes Bob 15 days working alone. If they work on alternate days, the number of days taken to finish the job will be Try this problem. Okay. Ten, 15. So work per day, 3 units, 2 units. Together 5 units. Now here they work on alternate days. That is A plus B, if they work on alternate days, that is in 2 days, one day A will work, one day B will work. How much amount of work will be done? 5 units, right? So one day A will do 3 units, the other day B will do 2 units, right? So in 2 days they will finish 5 units. Total work is how much? 30 units. So to do 30 units they take how much time? That's the answer. Okay. Let us take a similar kind of problem and see how similar or how different this problem is going to be. I'll just do only one change, just one change. Instead of 10 days, I'll take 12 days. I'll not even change the choices. Try this problem. Let us see just by changing one numerical how different the problem is going to be. Here we are talking about 12 days, here it is 15 days. LCM 60, 12 5s are 15 4s are, right? So A plus B, if you consider days, that is 2 days, how much amount of work is done? 9 units. So in 2 days 9 units are being done. In 2 days 9 units are being done. Now to do 60 units, how many days do they take? (120 by 9), that is more days, more work. (13 1 by 3 days). So you might be tempted to say none of this is the answer, but that is not so. Why? Why? Because of this fraction. In the previous problem, if you observe, you have got 12 days, right? 12 days was your previous answer. Now how are you going to divide? So you say 6 days A will work, 6 days B will work. They are working on alternate days, so it is very easy to distribute. Now if you have to distribute 13 1 by 3 days, how are you going to distribute? Please understand, when with this calculation you are getting some answer, there is some assumption behind that. A plus B in 2 days they are going to do 9 units. In how many days? They are going to do 60 units, which means clear cut assumption that A and B are getting equal opportunity, right? A and B are getting equal opportunity. So which means 13 1 by 3 has to be distributed equally. In that case, how are you going to do that? 6 for 12 days it is no problem. 1 1 by 3 days. 1 1 by 3 days. So 12 days it's okay. 6 days, 6 days. So remaining 1 1 by 3 days, how are you going to distribute? If you are going to distribute equally, that is half plus 1 by 6, half plus 1 by 6. Put together is 1 1 by 3, right? If you are going to distribute like this, then you are going to say for some part of the day A is working, some part of the day B is working, which is against alternate days concept. Against alternate days concept. Okay. So on the other hand, if you consider 1 1 by 3 as 1 and 1 by 3, it is against equal opportunity concept. So you don't want to do in terms of fraction. So one fellow is getting full day, the other fellow is getting one third of the day. Then the assumption here is they are getting equal opportunity. So that is problem. So you can't distribute equally, or you can't say one fellow more, one fellow less, without getting equal opportunity. So one thing is for sure, they are not getting equal opportunity, but both can't be satisfied, that is for sure. So if you go by the not getting equal opportunity, they definitely are not getting equal opportunity, then who should get more share, more chance, who should get less chance? How do you decide? The assumption is both are equally eligible for getting any number of chances, right? So here the data is missing in terms of who should get more chance. Who should get more chance? Then what is the required data? So what is that required data? It has to be like this. You take it as next question. If Albert starts the work. Try this problem. Try this problem. Let us take a break. After break, we'll be